Hi everybody. In this video, we're going to show that if you take any two elements, A and B in a group G, and you write down this, well, rather exotic looking product, ABA inverse, which is actually called conjugating B by A, and you raise that to the nth power, it's going to be the same thing as if you had conjugated B to the n by A. That is, you write A, B to the n, A inverse. Now we're going to prove this in a few steps, and we're going to use a little induction, but this should be a pretty easy induction. So this is actually asking us to prove it for all integers n, not just positive integers. So we're going to handle the negatives separately. Let's start with 0. That's kind of the easy case. When you write down the 0th power, you just mean the identity. So in this situation, AB A inverse to the n is AB A inverse to the 0, which is the identity. Well, A B to the n A inverse is equal to A B to the 0 A inverse is A times the identity A inverse. Of course, the identity goes away, and the A and the A inverse, well, they're inverses, so you get the identity. All right, so the result holds when n is 0. When n is equal to 1, well, AB A inverse to the n is just AB A inverse. And A B to the n A inverse is just A B A inverse. So yeah, they're equal to each other. So that's the easy case. All right, well, that's the base for our induction. So let's do induction on n. So we're going to look at the case where n is greater than 1. So in this case, A B A inverse to the n. Well, I can pull out n minus 1 of those factors. So I'll have A B A inverse to the n minus 1 times A B A inverse. And by induction, the A B A inverse to the n minus 1 is A B to the n minus 1 A inverse. And then I still have A B A inverse. But now the A inverse and the A here become the identity. The B to the n minus 1 and the B become B to the n. And so in total, I'm left with A, B to the n, A inverse. All right, so this handles all of the non-negative n cases. Now I want the negative cases. So the negative case, I'm just going to reduce it to the positive. So if n is less than 0, then when I write down A, B, A inverse to the n, this n is a negative number. So if I write down to the negative n, that will actually be a positive number. Of course, this is no longer the same thing, so I'm going to have to raise this to the minus 1, because now minus n times minus 1 is my n. Since negative n is positive, I can use the result I just proved, which is that AB to the times A inverse raised to the negative n will be AB to the negative n A inverse. And then I'm still raising all this to the negative 1. Now we saw in a previous video that if you want to find the inverse of a product, you're going to take the product of the inverses, but in reverse order. So I take A inverse and I invert it. I take B to the negative n and I invert it. I take A and I invert it. Now the inverse of an inverse is just the original element, A. B to the negative n to the negative 1 is just B to the n. And A to the negative 1, well, is A to the negative